Parametric equations. So up to this point, you have learned about functions that graph plane curves. And these are single equations that involve two variables such as x and y. So we're going to be talking about what if we want to introduce a third variable and it would still represent a curve in a plane. So here's an example of a plane curve. Y equals negative x squared over 72 plus x. And this represents the path of a propelled object, or an object that's propelled into the air, 45-degree angle, initial velocity of 48 feet per second. And there's a graph down there. You can see the origin at 0, 0, the vertex at 36, 18, and then the x-intercept at 72, 0. We also got like this little sort of directional arrow there. So even though this equation tells you where the object has been, it does not tell you when the object was at a particular location. So in order to do this, you can introduce this third variable that's called a parameter. And we're going to call it t, usually because it's for time. And then it's possible to write two functions for x and for y that are both in terms of t. And this is called parametric equations. And here are the parametric equations for this graph. So this set of equations is useful because you now know when the object is at these particular locations. For example, when time is 0, then the object is at the origin. When time is a little bit more than 1 second, then this is the location of the object. And when the time is a little more than 2 seconds, then this is the location of the object. So for this particular motion problem, x and y are continuous functions of t, and the resulting path is a plane curve. So here's some intuition to help you understand parametric equations. Let's say that for every degree the outside temperature is above 70, a convenience store sells X bottles of sunscreen and X squared pints of ice cream. So this could imply that ice cream is equal to sunscreen squared, but then it might seem that the demand for sunscreen directly changes the demand for ice cream or vice versa. And that's not the case. They're both influenced by the temperature outside. So it's better to write two separate equations, that sunscreen is equal to temperature minus 70, and that ice cream is temperature minus 70 squared. Graphs of plane curves. So when we sketch the graphs of plane curves that are written in a set of parametric equations, you're just going to choose values for t, and then you find the corresponding x and y values. And then you're just going to plot those points in order. And you want to do it in increasing values of t and trace the curve in that specific direction. And that's called the orientation of the curve. Let's have a look at example 1. All right, they want us to sketch the curve with these parametric equations when t is between -2 and 3. So I'm going to make a table. I'm going to have a column for t, a column for x, and a column for y. I'm going to choose the values for t. I'm going to choose from -2 all the way to 3. And to find my values for x, I'm just going to plug these t values into my x equation up here. When t is -2, x is 0. When t is -1, x is -3. So those are my values for x, and I'm going to do the same thing for y. So y is t divided by 2, and those are my values for y. And then I'm going to plot my x's and my y's just like I normally would when I graph a function. Okay, so I've set up my axes. This is my x-axis. This is my y-axis. I'm going to start with the smallest t. So when t is -2, my my graph is at 0, -1. And then I'm going to go -3, -0.5. Oops. So now I've plotted my points, and I want to connect them and indicate the orientation. So I started there, going around like so. So I went from that starting point, and then around, and then around, and then around. And you do not need to put an arrow on the end since we are only plotting these specific values. And that's the graph of my parametric equation, including arrows to indicate the orientation. Let's take a look at example 2. Well, it looks like I forgot to include the equations here, but the equations are x equals t squared and y equals t cubed. So same thing as before, I'm going to make a table of values. I'm going to have my t, x, and y column. And I'm not given any instructions for what to plug in for t, so I'm going to choose my own numbers. I'm going to go from -2 to 2, and I'm going to find my x values and my y values. And again, those values came from just plugging in t into each of my parts of my parametric equation. Now I'm going to set up my axes and graph it. Okay, I've set up my axes, and so now I'm going to plot my points. I have my points, and now I'm going to connect them, and I need to indicate the orientation. So I started down there, and then I went up that way, like so. And you, again, don't need arrows because you're just stopping at these points right here. Now, I did put a little bit of curvature to it, and you might be wondering how I knew that. Well, if you were to plot more points for t, so if you were to plot what happens when t is -1.5 or -0.5 or +0.5 and so on, then you would see that there is a little bit of a curvature to it. You can also get a nice picture of this graph if you graph it in your TI-84 calculator, and you should check out my video to see how to graph parametric equations in the calculator.